got a lot of that, and people used to make fun of me because I would say certain words with British or Scottish or whatever accent. And
I'm gonna test the stream.
anyway, not that it matters.
The stream has started.
I'm gonna play with the documents and make sure I can read them. Talk
Would
to you
somebody
later.
check the door? Because it's supposed to start in 5 minutes and nobody's in here.
Maybe nobody will show up. They'll go, oh God, Diane's speaking. We don't want to hear her.
Where's the thing here? Oh, there it is.
There's my microphone.
Tell them nobody can hear him.
Test, test, test. Test, test, test. You guys all waiting outside? Yeah.
Yeah, the door is closed.
The door is closed and locked.
It's not now.
I think.
Yeah, I think they got it open.
Yeah, they're always.
I don't know why I have this and listening on the stream while I'm doing this.
He's talking about Anzac again. Oh, sorry. I know. That's because
I recognize.
I'm far away.
Yeah. But I don't know what it's talking about.
Now I can hear you. I've moved my computer, and
This is good.
can you hear me?
Okay, that's good. Yeah.
Jeremy, come on over here.
Oh, okay.
Hey, hi. How are you? Haven't seen you forever.
Yes. I'm not showing up. Good. How are you?
Oh, I didn't leave your room here.
Oh, that's right.
Oh no, everything's all tangled up.
Okay, this is good.
Let me get you the link.
We're good.
Swear words.
Yes, that will fix it.
They're swear words. I know, ones that are not so shocking.
We're good. I think.
I know, I'm gonna try not to say any bad
That's so
swear
true.
words.
Right.
I used to work with a bunch of people with really fun mouths.
You're gonna get that YouTube channel demonetized now. We had it.
Okay, get your computer out.
Yeah. So I got Jupyter notebooks.
Yeah, I had to go walk away and maybe. Oh, sure.
See if it all fits.
Oh, sure. Yeah.
Oh, Jeremy, do you want me to help you with the HDMI setup?
I don't know. It's only until it fails that I realize, hey, I might need some help. So let's try.
So the key things are this, and then we have to, okay, so this worked perfectly, looks like.
Woohoo.
Yeah.
Okay.
So this is mirrored with this.
Yay, that's awesome.
Yep. And then the only other, do you mind if I touch it real quick?
Please.
Okay. The only other thing that we got to make sure is right is in the sound output, we want it to go to this.
Okay.
That's it. Other than
Oh,
that,
all right. Yes, let's see.
that's it.
The setups are incredibly simple now.
Yeah.
This,
Yeah.
this is great.
But once we have that,
no, I used the term tap handle because I thought that was hysterical when I read it in the book.
if our, I don't see our first speaker here yet though, so.
Okay.
Yeah, fun.
Oh,
In,
can,
I don't
hey,
know, 5
can
minutes
you,
or so, but-
can you send Jeremy the big blue button link,
Okay.
please?
Ooh, Wi-Fi. Yay.
Oh, are you,
It's a guest.
are you on it? If
That's
Qualcomm Hall is open, you
Okay.
get that one. It's wide open.
Okay.
And send it in the Discord direct message, cause text, phones don't work here.
Yeah.
good. Yeah.
I don't have phone service here.
Really?
I mean,
All right.
what are you doing over there?
Oh, good. Yeah, I wanted to make sure this sound and stuff was tested up. So
Well, we tested it with mine and it worked.
yes, but I wasn't set up for Wi-Fi and sound. Now we are.
Grease fire, not dumpster fire, just grease fire.
Okay.
Oh, grease fire. Grease fire.
We're still 5 minutes out, so 5 minutes. You don't need to set up right now. You, like, but I'm going to do introductions and then you're first.
Okay, so I don't know. Do I connect my laptop?
Yeah.
I
Do you have a laptop?
Yeah.
Does your laptop have HDMI? Does it have USB-C?
I don't normally have real coffee and I
Okay.
have this one.
That is a thing that we can make work.
Okay, he said.
I have a thing for code. I just have to remember to collect it. Okay, you're good.
I can actually have to see whether I can.
Okay.
I can actually.
I don't have a laptop. I'm not streaming, so let's see. And if you're on air, that's an air. Okay, you're good. USB-C should work fine.
Okay.
We have it's just an HDMI cable and USB-C, so you'll be fine. If you want to test it now, we have a couple of minutes. If you want to just hook it up, make sure that it. I don't know if you're going to do split screen where like your screen shows something different than the projector screen, or if you're just going to mirror.
I can just show exactly what it's.
Okay. It should show up, like what will show up there is exactly what will show up on this left
Okay.
TV.
Okay.
So yeah, it should just work. And do you have audio coming out of?
No.
Okay, great.
Mhm.
Then that simplifies things.
Okay.
Oh, you just have HDMI?
Yeah.
Oh, no. Oh, you have a mini display port.
No, I see Jeremy.
That is a thing we can work with. Hopefully. Shit. This is workable. Actually, I think they have one here. Let me check here. Let's see. This is HDMI to whatever, something.
Mhm.
This is HDMI to mini display port. This is what we want. So you don't need this. You need this thing.
Mhm.
And hopefully this just works. And this will not carry audio anyway. I don't think. So hopefully, this is not, no magic is happening. Okay. Do you mind if I touch it?
Yeah.
Okay. Displays. This one. And we want, why is this not coming up? It should come up. It doesn't, nothing comes up at all.
Yeah.
That's bad.
Yeah.
Yeah, we just had a feedback loop going because that was
If this doesn't work, maybe we'll find, this is where I'm at. This is, so the only thing it's showing is the built-in display. And that's the only display thing you have. Yes.
Yes, actually.
Okay.
We did test
Um,
that out.
Any way to use Hobson's computer fix?
Yes. Yeah.
Okay, let's do that. I don't know why this thing's not working. It's probably not your fault.
Yeah.
It's probably the fault of this is already going through something,
Mm-hmm.
and so that's the problem.
Do you know which Wi-Fi? it is?
Qualcomm Hall is open.
So I'll just share it with him online.
Perfect.
Okay.
Yes, please. All right. Thank you. Sorry,
Yeah,
but
no worries.
glad we tested it
Yes.
beforehand so that we
Yes.
didn't have to figure that out right now. Okay.
Is it gonna work? Let me shut my mic off. I'm not gonna listen to this. Laptop and stuff. Change the sound. Not working. We're good to go. I'm gonna sign up.
All right. The magic is happening. Hopefully, we don't. Hopefully, I don't. Got it. All right. Well, hopefully, we're good. Thanks for coming. You're in the right place for San Diego Python, and hopefully, I didn't like mess up the audio on the feed or anything. I think we're good. You're in the right place for San Diego Python. Thanks for coming. I'm David. I'm one of the organizers. I do want to thank Qualcomm for having us here. You know, the Qualcomm engineering development team, they've been awesome in letting us be here and run our event here. They've been great. And specifically, although they're not on this team directly, but Drew and Urivan for like being here, letting people in the front door, all that kind of stuff. So they've been great. I also want to thank my co-organizer, Jeremy, who's there in the green hoodie. He's helps wrangle all the speakers so we have good talks. So that's awesome. Cool. Couple small announcements and then we'll get into the first talk. We do have a Saturday meetup for San Diego Python. It meets online on Discord. If you want, so it's a little bit different from this one. There's not like a set speaker lineup or anything like that. It's kind of a bring your own laptop kind of a thing because it's online. And it's people kind of working on their projects and stuff like that, chatting. Sometimes people break out into different rooms. It's Saturday, 10 a.m. Pacific time, of course. It's online, and you can check either the meetup page or you can go to san diegopython.org, and that will have the invite to Discord and that kind of thing. Speaking of San Diego Python, that is our san diegopython.org. That's our website. It's like a one-page website, pretty much. Has a code of conduct, links to all the stuff, the meetup, the most recent video if you missed the meetup, the Discord, there's a link to like sign up for a talk. You should do that. Has a link to our YouTube channel where our meetups are streamed. That's happening right now. I also wanted to mention, so it has a link to the Discord. One of the key things in the Discord is the jobs channel in the Discord, which is all about, you know, people promoting or looking for a job, but mostly people like posting a job opening at their company. So that's definitely worth checking out, right? You know, there's 25 people in this room. Announcing your job to the 25 people is useful, but announcing it to the jobs channel on Discord, it's going to be seen by hundreds of people over, you know, a month or two. So that works great. I also want to mention just a couple upcoming conferences and events. PyCon US is in Pittsburgh. It's May 17th to 19th. There's the sprints and the tutorials are before and after those dates, but that's the core dates. So check that out. You know, you're probably already booked tickets if you're going, but it's coming up. And I also wanted to mention that there's a like 1 day, part of the day Flask Con. So for Flask, the Python web framework, that's happening concurrently with PyCon, one of the days. And the call for proposals, the call for papers on that is still open for the next couple days, like 5 more days, and then they're closing it out. David Lord would be angry with me if I didn't mention this, so I mentioned it. I also want to mention Wagtail Space, which is, Wagtail is like a Python Django-based CMS. That's in Philadelphia. It's on June 20th to 22nd. Check it out. I didn't know about it, but it's happening. North Bay Python, which is like a big regional Python conference in the North Bay, Petaluma specifically. That's on June 29th. So that's coming up. In years past, I know a bunch of San Diegans had gone there. That was because there's no like regional San Diego conference. People, North Bay Python and PyCascades were kind of the regional conferences that San Diegans went to. And then the last one, because this is the last one for the next couple months, is PyOhio, which is July 27th to 28th in Cleveland. So just love mentioning conferences and events coming up, so I figured I'd mention those. Awesome. I'm going to reiterate the call to give a talk at San Diego Python. You can sign up to give a talk on san diegopython.org. There's a link, give a talk. Sign up for it, and I am highly incentivized to get you to sign up for it, because when we don't get enough speakers, either I or Jeremy is a speaker. And so I would really love for you to be a speaker. We want talks at all the skill levels, not just, you know, like different topics, different skill levels. We're looking for everything. Whether you want to talk about advanced NumPy stuff, you want to talk about LLMs, you want to talk about problems with your first Django project, and all of these are great talks. And speaking has a 100% survival rate, so you'll make it. You know, it only has to be 7 minutes. You'll be great. And the last thing, I do want to mention our sponsor. This is JFrog. They're a DevOps platform for continuous releases. They've been fantastic. They sent me a bunch of swag, which is all gone, but I will get more. They sent me a bunch of swag like February 2020 to give out at our in-person meetups, which then didn't happen for like a year and a half. So thank you. I did give away all the swag. I mailed it until the meetups started again. Awesome. But if you need to host a PyPI inside your company firewall, they have a product for that that does that, and the same thing for like different languages and frameworks. So awesome. That's all my announcements. Our first speaker is Vish Bhat, who's going to talk to us about watermarking large language models. So awesome. And I'll let you take it away and hopefully get the audio working good.
Did you put it in? Oh, we need the USB-C.
Oh, there was a thing for that.
Got it.
No. I think I put one. Oh, I put it in my back pocket. Here you go. You can have this one. It'll not attach with it.
Looks good. Nice. So what you want to do is you want to just drag it over to the other side.
Yeah, you guys are pretty safe. Okay.
So you have to. It's really tricky. Basically, just look there when you're doing things. Let's see if I can.
And just make sure to talk clearly. This is the microphone that's picking you up on the stream. Okay.
There we go.
Yeah.
Wonderful. Beauty.
Thanks. Hi everyone, my name is Vish, and I'm a recent graduate from UCSD, and I was going through this paper, and I found it really interesting. It's one of the most cited papers of 2023. So I just wanted to share it with you guys what I learned from this paper. So it's called A Watermark for Large Language Models. So you know, since November 2022, when ChatGPT was released, we saw a rise in the number of cases of plagiarism fake news, election manipulation, and synthetic data flooding internet and stuff. So if you are developing your own LLMs, then you would be worried if your users would try to use it to use it for malicious purposes. So this paper discusses some approaches where you can easily implement a few algorithms such that you should be able to detect and verify if your LLM is being used for purposes that you didn't intend it to. So so I'll begin with a simple proof of concept. So like let's say you have an initial prompt, you take the last token in that prompt, right, and then you use that to generate a hash of it, and then use that to seed a random number generator. And using that random number, you partition the vocabulary of the LLM into two lists. You can call one the green list and the other one the red list. And then you make sure the LLM sources its tokens exclusively from the green list. So what's happening here is that because a normal human being is equal, for a normal human being, the chances of choosing any token is almost equally likely. But for the LLM, choosing one half of the vocabulary is way more likely than choosing the other half. So it's like if the number of generated tokens is t, then the probability that a human would write that kind of a sequence of tokens gets vanishingly smaller. So that's a simple proof of concept for this algorithm. But you guys might have already guessed this. But the problem with this algorithm is that, like, let's say there is a series of tokens that is an answer to your initial prompt, but unfortunately that has been partitioned into the red list instead of the green list, and the LLM is forced to choose from the green list. So what happens is that the LLM's performance suffers. Like for example, consider this prompt. The 44th president of the United States was Barack. The next word needs to be Obama, right? But if for some reason the token Obama falls into the red list, then the LLM is forced to choose from a series of tokens that all of them happen to be wrong. So such cases are called low entropy tasks, in the sense, so entropy is a measure of disorder in a system, or the measure of surprise in a probability distribution. So it's like in the example I just said, the 44th president of the United States was Barack Obama. The amount of surprise is very low in that. In the sense, we all know that the next word has to be Obama. So that's why this is called a low surprise, low entropy task. And I've also mentioned an example of a high entropy task, which is just write an essay on AI, or tell me how your day went. There are 1,000 ways you could approach that problem. So there is the probability distribution is more even. You know what I mean? So that's why there is like higher amount of surprise in it. So higher entropy. So this approach I just spoke about is very bad for low entropy tasks. So the authors talk about another algorithm, like a more sophisticated method to deal with this problem, and they call this the soft red list approach. So what they're doing here is that, unlike the previous approach where they are barring half of the tokens, here what they do is they just make it statistically less likely for the tokens to be sourced from that list. So in other words, the tokens will still be sourced from the red list whenever there is no choice, but it's statistically more likely for the tokens to come from the green list. So I'll explain that algorithm in a bit, but before that I'll go into how LLMs work under the hood. So like let's say you have an input prompt, a quick brown, and you have a series of tokens that constitute the vocabulary of the LLM. So what the LLM does is that it generates a logic vector for each of those tokens in the vocabulary. And so for the purposes of this presentation, a logic is just a number. After all the matrix multiplications and after going through all those activation functions, whatever ends up, that's the logic. So each token gets its own logic, and after that we calculate the softmax scores based on that logic vector. So a softmax function takes in a vector and calculates a probability distribution such a way that all the numbers in that vector add up to 1. So basically, a softmax score of a token could be seen as the probability of how likely it is to be the next token in the sequence. So here, the input prompt is a quick brown, and you can see that the token fox got the highest logic because the LLM predicts that to be the most likely next token. And when you calculate the softmax score for it, it gets a score of 99.6. So so this is what happens under the hood for most LLMs. So going back to the watermarking technique, so what they do is that to make the green list a little bit more likely to be chosen as the next token, they add a small constant to it. So here, just for as an example, I included antelope and bird as a part of the green list and fox as a part of the red list. So what they do is that they add a small constant delta, which they call the hardness parameter, to make it more likely that antelope and bird, to make it more likely that the green list tokens are chosen as the next token. And when you calculate the softmax scores, you can see that antelope and bird did get a higher probability, but but in this example, a quick brown, the prompt happens to be a low entropy task. So even though you did add that constant, fox ended up being the token with the highest probability. So basically, this is the proof that this approach can work with low entropy tasks, if you know what I mean, right? So and in cases where there's high entropy, in the sense there are 1,000 ways to choose the next token, then the addition of the small constant makes it a little bit more likely that the green list the tokens from the green list gets chosen. So with this approach, basically what you do next is you use a one proportion z-test to measure how with what kind of a frequency the green list is being chosen, and then you can determine if the watermark is present or not in the generated sequence of tokens. So now I will talk about detecting the watermark. So like I said, the authors are using one proportion z-test, and the null hypothesis happens to be that the sequence of tokens is generated by a human, or the other way to put it is the text in the sequence is generated with no knowledge of the red list rule. So and then they calculate a z statistic here. So here the magnitude of S with the G subscript happens to be the number of tokens that was found in the sequence that belongs to the green list. Gamma, the constant gamma happens to be a number between 0 and 1, which is basically the size of the vocabulary which is partitioned into the green list, and T happens to be the number of generated tokens. So if you look up the formula for one proportion z-test, the in order to calculate the z statistic, the equation is basically p minus p naught divided by root of p naught times 1 minus p naught. So if you if you substitute these numbers and simplify, this is the equation you get. So yeah, so this is the z statistic, and depending on the kind of confidence interval you're looking for, like for example, if you want to be 95% confident that the sequence of tokens was not generated by an LLM, then you'll have to look up the z naught score for that, which for 95%, I think it's 1.65. So basically what that means is that if your z statistic is above 1.65, then it is less than 5% likely that the sequence of tokens was generated by a human. So using this method, basically you can be certain up to a certain confidence level whether the sequence of tokens was generated by a human or by an AI. And with that, you could detect plagiarism, you could detect fake news, you could detect synthetic data. So yeah. So now I'll talk about some approaches or some ways in which you could try to beat this watermark. The authors of the paper admit that they don't have the solution for all these methods, but it's good to be aware of these approaches regardless. So one obvious way is to just paraphrase the generated output. So paraphrasing could be done either manually or using another LLM. If you do it manually, in a way, it kind of defeats the purpose because you are rewriting the whole thing, and stuff. The second way is to alter the tokens. So basically, what they're doing is they add dummy white spaces, or they kind of change. They try to intentionally misspell a few tokens, the attackers. So so that the hash value that is being calculated is different from the one that the LLM ends up calculating. So the red list would be different. So that way you can try to beat the watermark. So that's another way they have observed attackers try to beat their watermark. The third way is basically called homoglyphs and zero width attacks. So what that means is there are multiple Unicode IDs to represent the same character. Like A has several different Unicode IDs and so on. So attackers might try to use several different Unicode IDs for the same thing. And zero width attack basically means that there's a Unicode character called zero width, which is basically invisible. So adding that would also affect the calculation of the hash function. So what the authors propose to deal with such attacks is to normalize the text to, before passing it to the LLM, just bring it to one standard form. They call it canonicalization. That helps beat majority of the attacks that fall under those categories. The other attacks, tokenization attacks, basically what that means is if you add a new line character in certain areas, the byte pair encoding tokenization differs, so that will affect the hash function calculation. So that's another thing that they have observed in practice. And coming to the generative attacks, that's my favorite one because it's really interesting. I have two examples here. I don't know if this is visible. So what the attackers ask the LLM is to add an emoji after every token or after every word, and they get the generated response, and they take the generated response and then they remove the emojis. So now what happens is, because the response was generated with the emojis, the red list for that would be different after you remove the emojis. So the hash function calculation is all messed up, and you can try to beat the watermark this way. Another example of this kind of an attack is where you ask the LLM to substitute one letter for another. you take the response, and after that you resubstitute those original letters back. So because the hash function calculation for the original one was different, the red list is different, and you can beat the watermark. The authors admit that for this kind of an attack, they haven't found a solution yet, but the research is ongoing and it's interesting. But if you guys notice, with this example, some of the words, even when you resubstitute the original letters back, make no sense. It's because you're imposing a huge burden on the LLM to substitute the letters and then think and come and write a good essay at the same time. So what's happening is, so basically what the authors are trying to say is the attacker is also taking a hit when they use an attack like this, because the quality of the generated response suffers. So yeah.
But you're showing the text without swapping the A and the E back. If you swap the A and then the E back, does it start to look better?
Yeah, no, I said even when you resubstitute those letters, it's some of the words there still don't make sense.
Okay, I don't see any of the words there that they all look right to me. If you switch A and E, they all look perfect.
Yeah.
Look at the first word.
Yeah, the first word, it doesn't make sense.
Starting.
Although the first word is response.
Substitute the word A for E, and you get starting.
That's the
Substitute
problem.
the word starting and ice.
No,
cream,
in the response. Like look at Fram.
Okay, I got it. But are you sure that's the technique that they recommended using? Because that doesn't look like that looks like it would be a useless attack.
No, this is something they observed in practice.
Okay. Yeah. I think you can do that attack differently. Yeah. No, like I said, this is the one attack that they don't have a good defense for, and research is ongoing for this kind of attack. But yeah. The last one is span replacement. So basically that means you replace a series of tokens with a mask, and then you try to do masked language modeling with another model. So like you could use a T5, or you could use I don't know, GPT-2 or something, and yeah. So there is no, as of today, there is no strong defense against this kind of an attack as well. But yeah. So that's it. If you guys want to access the paper, here's the QR code, and I hope you enjoyed the presentation. I know you happen to be working on an LLM yourself, or at least a collection of LLMs. How are you thinking about using a watermark system like this? What's a good application case for it?
Yeah, no. So one way some of our competitors might try to use the superior technology we're developing at our company is by by attempting to fine-tune their models on the generated responses of our models. So what I'm planning to do is, I don't know if it's being recorded, but I'll say it anyways.
It is being recorded. So don't say anything that you don't want to share.
Yeah, no, I mean, one way that I might try to do is use multiple keys, multiple ways to split the green list and the red list in a way that only I will know it, and yeah.
Basically, you'll encrypt the watermark.
Yep.
You go first.
Oh, let's see.
So it sounds like if you're generating a college essay and you set the randomness to 0, that this can fingerprint which, statistically likely, which LLM generated this particular college essay. But if they set the randomness to, let's see, 10%, 20%, it gets harder and harder to trace down which LLM generated the essay.
So when you say the randomness, do you mean the p-value? Like for the one proportion z test, do you mean the p-value?
While you're generating what the randomness of the next word token is going to be.
Oh, yeah, no. Sorry, the randomness, like, are you talking about temperature and stuff?
Yes.
Yeah, no, temperature is different from the randomness that I spoke about. Yeah, like they're completely different. This is for the watermarking stuff. And here the random number is generated by the watermark implementation and not by the LLM. Yeah.
I'll let other people talk.
Yeah, what I don't understand quite is the partition of the tokenization. In the sense that if I make a red list and a green list,
Yep.
if I always use the same red and green list,
Yep.
then I can do simple statistics on the dictionary that is used by the LLM.
Yes.
I know the red list and I know the green list, and I can make very specific attacks. If I always use a different red and green list,
Yeah.
then if I'm doing statistics on that afterwards, then I'm doing multiple testing. Meaning I would have to test for multiple red and green lists, which makes my statistics much more like weak.
Yes.
In, like, detecting whether it is an attack. How is that solved in this?
Yeah, no, this is a good example of that. So what they're doing here is, because they use the emojis, it's like, in a way, you get the same red list and green list. And when you remove the emojis, and then you use the response wherever you want to use it, the red list and so basically what the authors are trying to say is, you could do this red list, green list partition after every token. Or you could do it after, say, 100 tokens, or you could do it after 20 tokens. You could experiment with the numbers, the frequency at which you want to do it. So it's not fixed. Here we're using a simple example, but in practice you can play around with the numbers and see what works best for you.
The watermarker knows exactly the algorithm for generating the red and the green list. The attacker and the detector also knows the exact statistics of how the watermark was generated.
Yes,
The attacker does not.
How does the attacker not know if he can do 1,000 bombs and then do the statistics?
Because it's just like it's the enigma problem.
Okay.
They're changing the code
So it's not a fixed red and green
Yeah,
list.
yeah.
The red and green list changes.
It changes with every token.
Yes. Yes. It changes with every token, or you could change it after every 100 tokens or every 50 tokens. You could do what works best for you. Yeah. And the other thing is that in the appendix or something, they try to calculate. They try to see if you could make repeated requests to the LLM with similar prompts, and then try to find out how it's trying to partition the red and green lists. So they try to come up with a number of requests, like that you need in order to find that out. And you can see if the person who's using the API is making that many requests with similar prompts, then you could kind of alert the system or something. But yeah. Mm-hmm.
Awesome.
Okay. Thank you.
Thank you.
Thanks, Vish. Cool. Our next talk is a little bit of a longer one. And it's going to be a 3-person talk with 2 of them remote and 1 local. And this is Trevon Babcock, Diane, our co-organizer, and David Neal, and they're going to talk to us about about dictionary and function combo versus classes and data classes showdown. So that's it. And you have HDMI directly, right? Yes. Okay. So I need to make sure that I'm capturing the output from. And Diane, you wanted no video.
Yeah, because, yeah.
Okay, I'll make sure to turn the video off. Oh, yeah, and the output is set to Crestron. Perfect.
Alrighty.
It just fell out. Okay, I'll just put it up here.
Computer, actually.
There we go. Testing.
Okay.
Hey, Trevon, let's see, can you talk? Trevon?
Yeah, I'm here. Can you hear me?
Woohoo! Okay.
Testing. Okay.
Me
cool.
too.
David,
Awesome. Okay.
is
good.
David there?
Yes, we've got everybody.
Did he talk?
Yes.
Okay, I'm
just-
closing Discord.
I'm going to maximize this.
He wanted me to close Discord, so whatever. All right.
You wanna? And I'm gonna turn the video.
Everything or all the font sizes are on his side. So
Yeah.
let's see. We could use a zoom in on the fonts.
Yeah, he's hopefully gonna get that set up.
Options. Don't allow.
Oh, I can watch on here.
Yeah.
He's organized, but there is a delayed repeat coming through about 10 seconds late.
Ooh.
Uh-oh, that's not good.
We got
I'm not sure if there's much we can do about that. It's probably them speaking and then the microphone is picking it back up. The internal microphone is picking it back up.
Okay.
I wonder why this one's doing that and that one isn't doing that.
Let's see. I've got the mic turned on this device, so he's hearing it through maybe YouTube as well.
You don't have like a stream going, do you, David?
If you've got YouTube,
Yeah, that'll be the fault.
Okay. Yeah.
Okay. Good.
If you turn off YouTube, then you shouldn't get the repeat. So.
All right.
Then I couldn't see your beautiful faces.
Right.
Oh. Let's see.
What?
He was looking to find out whether or not you could see us. Okay. All right. So.
All right.
You can watch it. I'll watch it in the recording. But there's not going to be a recording. So.
Yeah. So David's in New Zealand. Trevon is in Lompoc, and I'm here holding the bag. And I gotta scroll back to the beginning of my script so that when it's my turn, I know.
Okay, we ready to go?
Yeah, I think so. Go ahead.
Rock and roll.
Okay. This is Trevon. We've been developing a Rolodex phone book program at our Saturday study group. Each week, beginners like me take on more advanced challenges. Tonight, I'd like to turn the tables and see how more advanced members would tackle a similar problem. The initial specification is to record details about a person, the given name and family name for each person in the Rolodex. Diane, can you show me how to do this with dictionaries?
Oh my God, my computer just went blank. What happened? Speak to me. Oh my God. Hello.
Got it, Diane.
I know, my computer just, hello. And blank and it's not waking up. Why me? Yeah, we can do that with, what the heck is going on? Okay, I don't understand understand. When I turn it like this, it goes blank, and when I have to hold it like this, then it's fine. Oh my God, what's going on with my computer? You wouldn't know any more than I would.
Probably not.
Yeah, okay. Whatever. During our weekend sessions, we started working with dicts. So let's open the IDE and in good style add the doc string. And are we okay? Okay, we're gonna have all that. So we have person details in the dictionary, and so we're gonna employ a dict to represent a unique person. So let's build some sample data. Yay. So we have Fred as the given name, family name Flintstone. Yay. And now to have a second one, we have Barney. And the same amount of effort is required for every individual. So now we have our sample data. So how will we retrieve the data about a particular person? Can the individual data fields be retrieved? So printing Fred and printing Barney. Excuse me. And we can print Fred's given name and Fred's family name. So let's see the result of that. Woohoo, it worked. Now it's David's turn to talk. Speak to me.
It kind of helps if you've got your microphone on, doesn't it?
Usually.
This code gets this code gets the job done, but there's no mention in the output there. There is absolutely no mention that the dict represents a person. In fact, even inside the code, it's difficult to see that a person is being represented. But we're computer people. We know what this report is all about, right?
Well, you made that look easy. I've just realized two things. I'd like to be able to use the two separate names joined together and formatted as first initial plus family name. Can you do that? Oh, and yes, earlier I forgot to mention that each person needs to have a phone number. This is a Rolodex app after all.
Yeah, sure. We can implement the first improvement as a function. We need to separate out the first letter of the person's given name. Since it's a string, we can get the first element of the string using the index. The function accepts the dict and returns a neatly formatted name. So to use the function, we just call it and pass in the person's dict. Are we done here?
Yep.
Okay, cool. There we go. In the function definition, do we see the function definition? Where's the function definition? I've lost it already. There it is. You notice the type, dict, describing the person parameter, and the arrow stir that is between the function's closing parenthesis and the colon. What is that? Those are type hints. We'll be using more of those as we go along, so bear with us with that. So the next task is to add the new field to the dict. It's necessary to reword the lines defining each data construct and assign the new key value pair. So where do we define Fred and Barney? We need to give them, yay, phone numbers. And the code retrieving the details for the person will still work. But if we want to see the new field, then we need to add that in. There we go. Yay. Oh, we have to actually see it run.
Having computer problems today.
Uh-oh. You're not allowed to have computer problems when we're doing this. All right, yay. There's the phone numbers.
So it works, but are there criticisms of this approach? The output still lacks labels. I guess we could add something in the print statement to make that right. Regarding the new field, what would have happened if we had updated Fred's data but forgot about Barney? Right. So up here. I guess a crash would have occurred. We would have ended up all over the floor. I guess we could make it a default dict, but you know, there's more work involved in that. Regarding the new function, what are the disadvantages of this? Right, the first thing is that the dict function and the dict definition are separated and could be separated by hundreds of lines of code. We need to remember to feed the function into the, to feed the dict into the function. That's in the signature, and there you go. The IDE is making that a little bit easy, so it's not too tough. The dict parameter itself must have 2 keys. And they must be exactly as named. Otherwise, it's not going to work. So, in programming terms, big issues relating to coupling and cohesion.
This is great. Okay, so there's many person entities in a Rolodex, but we don't want to have the same person in twice. And we want to keep it organized alphabetically. Can you do that for me, please?
It's not as easy as you might imagine to make these kinds of implementation changes. In this case, to enable comparison and to sort multiple person entities. 2 similar entities may be compared to establish whether they are the same or not. Like whether Fred equals Fred, Fred equals Fred, or Fred equals Barney. And then if we have Fred at work with the same given name, the same family name, but a different phone number, what happens when we compare Fred with Fred at work? So that's interesting. And then to the second half of the request, if there is some sort of collection of person dicts, like, for example, you have a list of them, can they be sorted into some sequence? Did we try that yet? The comparisons work, although Fred does not equal Fred at work. Do we want that or not? We don't know yet. But the sorting crashed because the sorted function doesn't understand how to sort dictionaries.
So how could such a test be made to work? And I guess it depends on how the user wants this to work. Worse, there's nothing to stop a person dict being compared with some other entity, even though it would make absolutely no sense whatsoever to try that. There is no built-in function or method to sort multiple dicts. There are some fairly clever ways that people have rolled their own solution, often involving converting the dicts to tuples, sorting those, and then recreating the dicts, but this is a major limitation. Basic data constructs quickly run into such limits when applied to more advanced operations. In this case, the formal error is that addict does not support Python's rich comparison operations.
So if using dicts aren't going to cut the mustard, what would a more experienced programmer do?
Additionally, representing the person entity as a class offers more capabilities. It's a bit more work up front, but it gains greater potential for the long run. Oh my God, my computer's dying.
Okay, let's try class and start from the beginning with one that will record the given name and the family name for each person.
All righty. So we'll borrow the opening comment from the dict code and edit it to refer only to defining the data entity. So the class needs to be defined with the name, and best practice is to use the capwords convention when naming classes, and of course, including a docstring. So the next step is to describe data values as parameters in the dunder init method, and then to assign each as an attribute of the class. So this is a lot longer than the dictionary definition, particularly when you still have to add the code to create each person. That looks like we're calling the class and assigning values, which is how each person entity is created. We call this process instantiation because it creates an instance of the class. Retrieving the entire structure appears much the same, but retrieving an individual value, an attribute, involves much less typing. When we have a class instance, we can use the dot notation to access attributes of the instance. There we go. So that's without we don't have to have all the brackets and quotation marks, so it's a lot easier to read. So what happens when this is executed? The individual data fields come out as before, but what's with all that main.person stuff? That looks like nonsense. So to get rid of the substandard output, that is to say, to tell a class to describe itself, we have to code an extra method called dunderrepper. This can be whatever you want, but is usually considered the developer representation of the class instance. And so the dunder class dot dunder name, which is kind of hard to read on there, will get us the exact name of our instance. In this case, it will always be person, but you might like to note that it is a good habit to use this for the dunderrepper in case of more complicated situations that we're not going to discuss today because it would take till next week. Not really. How does this improve the output? So I think there's going to be some screen jockeying here so that we can display the comparisons.
Oh, somebody must have messed it up. It's so hard to get good hired help for you, Diane.
Okay.
It is there on screen. You've now got descriptive persons.
Yep, and it's your turn to talk.
Not only has the meaningless output been repaired, but compared with the dict output on the left-hand side, and I'll scroll to make that a bit easier to read. There we go. There's a label to say that this data represents a person. The combination of name and values is invaluable, especially if you have a habit of using debug prints, or even helpful when you are using a debugger. Comparing the class output with the original result from dict. Once again, like the code, the output is a lot easier on the eyes because the quotation marks are no longer cluttering up the place. However, when we go back and compare the code, we have a lot more going on here. The class definition makes the initial implementation a lot longer than our dict implementation. Thus, it takes more developer effort to code. Is the extra coding worth the advantages of dotted notation and meaningful data construct naming?
Yes, good question. Is it worth it?
Maybe the answer to that depends upon how much effort is required to make the improvements you're going to ask for next.
You read my mind. The two user changes are to add a new data item for the phone number and to format the name.
Okay, we'll start by modifying the dunder init and add a new phone parameter and phone attribute. That's the class definition changed. To make it work, the extra values need to be assigned at each instantiation. So let's, yeah. There we go. And a little further on, the individual value retrieval step also requires augmentation to get the phone number. There we go. So the instances are being provided with the extra data and the class is ready to hold the value, plus it can be output. Ready to run?
It works, but hold on, is there something missing?
An error here. The phone numbers are missing from the person display. The dunder repr is not displaying all of the fields when the code is supposed to be retrieving all of a person's data. So we can fix that by adding the new attribute to the dunder repr method and run it again eventually. Yay. Now the output is correct to spec. So the second request was to format the name. Because the class encapsulates its data, this is easier to code by adding a method, which is a function within the class. And again, we can snag the first letter of the given name and put it in the string. Cool. So compared with the dictionary approach, the call is essentially the same, except with a dict, the function is what it's all about, and it operates on the dict. When using a class, the instance is the subject, and the method is the verb. Here, there's no danger of using the method incorrectly, as was a concern with the dict function, because our code is encapsulated within the person class. Similarly, the data is expected to be part of the class, so there's much less risk of confusion. So the method can be called directly from the mainline code. Cool. But wait, there's more. We like to save typing. So let's turn the method into a property. Have we done that yet? No. David's got the hard work. Yay. All right. So now the method call no longer needs its parentheses because the property behaves as if it were a data attribute. Thus, we can change the call to look like this with no extra parentheses. Not only is it a bit less typing, but best of all, we have fewer of the pesky shift top row keyboard characters to type for those of us that are klutzy like me. So let's run that. And that works. Yay. We have the same result, but without the parentheses in the calling code. So it looks cleaner. Less boilerplate and fewer punctuation symbols. Properties are kind of like magic. They're not really magic, but if you don't know about properties, they kind of seem like magic. They make a method behave as if it is a data attribute. That's another thing we're not going to discuss here. Otherwise, this talk will go on forever.
And properties can't be easily added to dicts. So the problem we've experienced here is that with each change that the user wanted made, there was a need to go through each method and every call to ensure that not only is all the required data provided, but that it is applied where it is needed. In this case, only the dunder init and the dunder repr methods needed to be upgraded. But in many situations, there'll be amendments to far more methods. Adding the formatted names functionality within the class and the property makes for much cleaner code and leaves us less open to mistakes in usage.
This is getting a bit sophisticated. Do I need to learn all this? I could stick with dictionaries. Let's see, using a class, can we implement the comparisons to avoid duplication and alphabetize the data?
Now, with the next set of user changes, the specification can be tightened in a way that is all but impossible with dict. From now on, the comparisons will be made between given and family names only. The first task is to define how class instances are compared by adding a dunder EQ method to the person class. Oh, I wish I could read that. Oh, yeah, there it is. The comparison is made between this person and some other entity, which does. Oh, if the comparison is made between this person and some other entity which does not represent a person, it will most likely fail. But we don't have time to discuss duck typing or protocols. We're just going to pretend like it's always going to be a person. So let's check that with, yeah, Fred equals Fred, Fred equals Barney, and Fred equals Fred at work. So now Fred equals Fred at work becomes true. So now, what do we think about sorting a group of people? Sorting dicts is problematic. With a class, now that we have an equality comparison, all that's necessary is to provide a method which defines a less than comparison, with the additional advantage that the sorting criteria can be customized to suit the user specification. In this case, that the phone numbers are not used to differentiate between persons. It's almost the same as the dunder EQ method because it involves the same two pairs of attributes. Cool. We're going to see, we are going to want to see nicely formatted output of our list of person instances. So we're going to import the function pp from the pretty print library. And now if we copy the sorted step over, it's going to work this time. Have we done that yet? There we go. Isn't that pretty?
The takeaway is that the powers of classes keep expanding long after dicts and similar have thrown in the towel. Flexibility and power is limited only by the functionality the programmer can add into a class's methods.
For some weeks now, Diane has been talking about something called data classes. Is what you've just developed a data class?
No, it's close, but not really. We created a traditional class or object. A data class is sort of like a twin, same but different. What is meant by that last comment is that data classes can be thought of as a drop-in replacement for a traditional class. Let's prove that by copy-pasting the calling code from the previous solution. It won't execute immediately because there's no class definition yet, but we know what to expect. So in best TDD style, we'll work on getting rid of all the red step by step. So to use a data class, oh, wait, I'm ahead of him.
You're always ahead of me, Diane.
What can I say? Okay, where are we?
We've executed the code that we copied over, and we've got some red ink on the page.
Yeah. Okay, so now we're going to define the class starting out in the usual manner with the class person and the doc string. But then we're going to decorate it. Oh, we need to import.
We need a computer. Has anybody got a spare computer? Yes.
So we need to import data class from DataClasses library. Somewhere up there. Yeah. And then the class is decorated with data class. And one of the cool things, there's lots of cool things, data classes don't need a dunder init. Instead, the attributes are listed under the class name. Note that data classes stand on the shoulders of giants by requiring type hints. We hope you're a fan of typing, or you might get kind of grumpy about this whole thing. On the other hand, we don't need to code a dunder init method, so we're already way ahead. We'll make you a fan yet. Also, if you're experienced with traditional classes, please don't get confused. These are instance attributes, not class attributes. It's possible to make class attributes in data classes, but we're not going to talk about that here either. There's lots of stuff we're not going to talk about here, because otherwise we'd be here till next week. All right. So this is an elegant approach. It's clean, easy to read, explicit in its intent, and more. The class definition is a lot shorter than its classic cousin or twin, whatever you want to call it. Also, note that the earlier class was first used without a dunder repr. So there's no dunder repr here either to be able to compare apples with apples. Moving on to using the data class, the existing class calling code has been copy-pasted without a change, but the phone numbers haven't been added to the class definition yet. Are there any improvements when the code is executed? Oh, look at that. There's no need to code a dunder repr. How about that? Oh, no. He was supposed to say that. But I'm so excited I had to say it.
There we go. There was an error in the execution, so I spoiled your nice display. Sorry about that. Yes, there's no need to code a dunder repr. The data class constructor gives us a dunder init, a dunder repr, and a dunder str with a bunch of helper functions, all for free and straight out of the box. Can you see that the data class code is considerably shorter than that of the traditional class? And comparing with the dict implementation, there's still quite a bit of coding overhead, but the improvements in readability and the improvements in the calling code itself are well worth it, in my humble opinion.
Okay. We're starting to see some advantages. How about when I, the user, ask you to add another data item and to format the name?
So adding the new phone number attribute couldn't be easier. We just add a line to the definition. Yay. No need to modify the dunder repr. Since it comes for free with every data class, it's automatically updated whenever the data class definition changes. The calling code will need to extend the instantiations, same as for the standard class, and also the retrieval of the individual values we would have to change because it can't quite read our minds. Getting there, but not quite. Oh, and we can ignore the exceptions at the end. We'll get to that. So how can the extra functionality be added? We can copy the method from the traditional class. They're exactly the same. So in the interest of speed, we'll just throw in the property right away somewhere. Are we in there? Yay. Similarly, utilizing the name functionality from the main line is exactly the same with the dot notation and the attribute.
There we go. It's worth repeating that this is proving how a classic custom class can be replaced with a data class or refactored into a data class with zero impact on the calling code. There is no change to the calling code between using a traditional class and a data class. And you even notice that we borrowed a method from the traditional class and just used it in our data class.
Wow, that was fast. So much less work. Can you maintain the rapid momentum when implementing the comparisons to avoid duplication and to organize the Rolodex alphabetically?
Let's see if I can blow your mind and maybe a few others. What we do to empower these features in the data class is maybe going to surprise you. Whereas the traditional class required 2 new methods to be coded in order that the class can handle comparisons and sorting, and potentially could have needed another bunch of further methods for other types of comparison for a total of 6 methods for augmentation. Augmenting the data classes with the same capabilities couldn't be easier. We add a single parameter to the decorator, and data class will generate all 6 comparison operators automatically, which also means instances can be sorted. So it's exactly the same result as for the traditional class. By the way, there's a number of other parameters which one might choose. What?
Not true.
Why did you put that in the script?
It's
I wasn't. Which part's not true? Oh yeah, the comparison, because we're comparing everything. All right, whatever. We'll get there. We'll get there. It's almost all true. You put
baby steps, Diane. Baby steps. Yeah, it's got to be somebody else. It's got to be the computer's fault, Diane.
Okay. Yeah. Okay, but let me say, by the way, there's a number of other parameters which one might choose to apply to a data class. You can check the docs for details. Okay, but here's another. But wait, there's more. The output looks correct, but in fact, the comparisons here are being made between all three attributes. But we want the phone attribute to be ignored for sorting. Okay, so the fields of a data class can be controlled in many ways. Time does not permit detailed discussion, but we're going to consider two different ways. So it's possible for a person to have only one name. The term for a person with only a single name is mononym. It's unusual in a Westerner, but it happens in some other cultures. So the family name in person should be made optional. If it's not entered, then we should store an empty string. So the format for that, when in the data class definition, is probably what you might expect, and yeah, shorter than the method usually used with mutable objects, so we don't have to worry about using none as a default value. So it's possible to tailor the behavior or characteristics of attributes in other ways. Too many to mention today. The data class library offers a field helper function, which adds or controls such things. So we're going to import the field from the data class library. Oh, I lost my place. Here we go.
Try again.
Yeah. In the case of the phone attribute, we can add a default value and we can exclude it from comparisons with a single call to field. Yeah. And now we can add a mononym person. If we go down to where we're defining people, there we go. And now let's add solo to our sorting process. Oops. There we go.
And there's a dict on the left, and there's a class on the left. So we're now equal to class.
Yeah.
So a dict is very easy to write and to start using. However, its capacities are limited, and advanced usage soon proves that it's not suitable beyond a certain point. A traditional class requires much more typing to start using it compared to a dict, but one can keep adding more and more methods and thereby increasing the class's capabilities and powers. Both types of classes offer cleaner expressions courtesy of the dotted notation, whereas dicts involve pairs of square brackets and probably key values surrounded by quotation marks. A data class sidesteps the getting started issues by generating commonly used methods and making them available out of the box for the price of invoking a decorator. Similarly, methods may be added to provide the same level of capabilities and powers as its traditional cousin. When it comes to those small little changes that users seem to love bringing us, which of these data structures realizes their hope that it won't take you very long? Dicts, classic classes, or data classes? Dicts can add key value pairs easily, but will probably require great care to ensure every single one of such structures are updated. It can be difficult to add advanced functionality, although you could consider using collections.userDict, for example. Whereas a class allows for further methods to be added at very little cost. That said, if the amendment adds or removes attributes, each method which uses or should use that attribute will need to be amended. In the case of data classes, all of the earlier advantages apply, and any attribute additions or subtractions will be handled automatically in each of the methods generated by the decorator, saving you, the programmer, time and effort. Thank you.
Any questions? Cool.
Questions about data classes?
Great. Thanks everybody for putting up with us.
Too easy.
Thanks to the remote speakers too.
Yeah. Yeah. Thanks, Trevon. Thanks, David.
Thank you.
Pleasure.
Questions, huh?
No questions. Good. They're stunned.
I thought that was great. Thank you.
Thanks.
Awesome. That pretty much wraps up the meetup. Thanks for coming. I do want to give thanks again to our speakers, the remote ones, the ones who are here, everybody. You too can be a speaker. Sign up at the website, sandiegopython.org. And I also want to thank, again, just Qualcomm and JFrog. They've been great. And thanks for coming. We'll be here next month. All right.
Thank you.
Awesome.